Hello, hello. Okay, let's get started. So it turns out they were like just not picked up from the printer. I accidentally separated it. So I just restapled it now. And we can resume. Let's see, we're gonna do number 12. Um, just checking something. Okay, so I'm gonna go ahead and cheese it a little. Wait, let me see, can I? Oh, it's different. Oh, okay, no, I won't cheese it at all. Alright. So let's start. So it's 4 minus x squared. So that means we need to use this method where it's x is equal to 2 sine of theta. It means x squared will be 4 sine squared of theta. And that means dx will be 2 cosine theta of d theta. Okay, so we're going to plug everything in. We have the top just be 2 cosine of theta. And then we have the bottom being 4 sine squared of theta. Square root 4 minus 4 sine squared of theta d theta. If you factor out the 4 under the square root, you'll get 2, and that will cancel out. So you'll have a cosine of theta, sine squared of theta, square root of 1 minus sine squared of theta. That's just going to be cosine, so this will cancel out. And then we have 1 over sine squared of theta d theta. And then this is technically just cosecant squared of theta d theta. You have a formula for this. Cosecant squared is just negative cotangent of theta plus c, and then you need to figure out what cotangent is. So that means you're using this, which is opposite over hypotenuse, and you need adjacent for that. So it's 4 minus x squared. So our final answer is negative. This is adjacent for x minus x squared over opposite x, and then plus c. Right? Where's my solution? Okay. Sweet. Okay, good. All right. Let's do this one next. This is screaming partial fraction decomposition. So let's do that. First, we need to factor out this guy. And we definitely can. X squared minus 4x plus 3, no matter what method you use, you should get x minus 1 and x minus 3. So that means the inside of this, which I'll denote in a different color, 3x plus 5 over x minus 1, x minus 3 is equal to some a over x minus 1 plus some b over x minus 3. Now, the reason why we use a and b is because these are linear factors. So you only use the linear numerator for a quadratic factor. In that case, 3x plus 5 has to be equal to a times x minus 3 plus b times x minus 1. I'll distribute that to be ax minus 3a plus bx minus b. A plus b then must equal 3, and then negative 3a minus b must equal 5. I'm going to go ahead and combine these because that will just get rid of a right away. So that's negative 2a is equal to 8. So a is equal to negative 4. And then that means b is equal to 7. I'm just double checking. Yeah. Okay. So then we can set this up to be negative 4 over x minus 1 plus 7 over x minus 3. So you can rewrite this integral to be negative 4 over x minus 1 plus 7 over x minus 3 dx. And that's just going to be negative 4 ln of x minus 1 plus 7 ln of x minus 3. And then plus c. All right. Oh, I keep forgetting. I'm pretty sure I've been forgetting to do it for the other ones as well. Let me see. Yeah. Absolute, 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 absolute. The absolute of this one. Okay. All right. Next one. We see that that's pretty easy to factor. It's x times x plus 1. So that means we have a over x plus b over x plus 1. Multiply the denominator by on both sides to get a times x plus 1, and then b times x. I'll distribute this ax plus a plus bx. And this right away tells me a is equal to 3, and then a plus b is equal to 2. So that means b must be negative 1. So this can be written as 3 over x minus 1 over x plus 1. Let me see. So that means we could split this up to be 3 over x minus 1 over x plus 1 dx, and this is 3 ln of x minus ln of x plus 1, and then plus c. All right. Let's go again. Here, by somehow you will see that that bottom part is factorable into x plus 2, x plus 3. So that means 4x plus 1 over x plus 2, x plus 3 can be rewritten as two linear factors, a over x plus 2 plus b over x plus 3. And 4x plus 1 is a times x plus 3 plus b times x plus 2. Distribute those. And after distributing those, you can set up what they need equals. So a plus b needs to equal 4, and then 3a plus 2b needs to equal 1. So I'm going to multiply this guy by negative 2 to get negative 2a, minus 2b equals negative 8. And then combine these two to get a is equal to negative 7. And that means b is equal to 11. Using that guy. Yeah, okay. So then we add this in, negative 7 over x plus 2 plus 11 over x plus 3. Rewrite this guy. negative 7 over x plus 2 plus 11 over x plus 3 dx is equal to then negative 7 ln of x plus 2, excuse me, plus 11 ln of x plus 3, and then plus c. Okay, pretty straightforward. All right. Last one. For here, you see the bottom is x squared plus 3x plus 2 is equal to x plus 1, x plus 2. So you have 3x plus 7 over x plus 1 times x plus 2 is equal to sum a over the x plus 1 plus sum b over the x plus 2. Then 3x plus 7 is equal to a times x plus 2 plus b times x plus 1. Distribute. And then evaluate that a plus b must equal to 3. And then 2a plus b must equal 7. So we're going to take this guy and subtract it this guy. So we should have that a is equal to 4. If a is equal to 4, then b is equal to negative 1. 4 over x plus 1 minus 1 over x plus 2. And then go ahead and plug this in. 4 over x plus 1 minus 1 over x plus 2 dx is equal to then 4 ln of x plus 1 minus ln of x plus 2 plus c. All right. We're down to the wire. We have 17, and then I know I had this typo, 18, 19, 20, and then 21. All right, let's go. So this says, oh, I forgot to write the rules. Okay, because that's going to be provided. The rules will be provided. I'm going to literally like copy and paste the, I'll probably include the body of the question just because you're only going to get one of these. Spoiler alert. Um, but let's see. Okay. So step one, so hopefully you have it handy. Step one is to figure out the change of x's, which is just the ending point minus the starting point over the number of rectangles 4. So it's 6 over 4. That's going to be 1.5. And then we need to figure out all of our x's. So x0 is 1. x1 is 2.5. X2 is 4. X3 is 5.5. And then X4 is 7. I'm going to go ahead and rewrite these to be in fraction form just so I can have them. Because I'll probably use that over not. So that's going to be 5 over 2. And then that's going to be 11 over 2. Okay. Let's go ahead and then do, excuse me, let's do midpoint. So 3 is, let's do M1 is the average of those two. 2.5 plus 1 over 2. That's 3.5. So 1.75. Midpoint 2 is 4 plus 2.5 over 2. And then that's going to be 3.25. Midpoint 3 is going to be 5.5 plus 4 over 2, which is going to be let's see, 9, so 4.75. Then midpoint 4 is going to be 5.5 plus 7 over 2, which is 6.25. Okay, just double checking. 4 is us plugging in all these values, which I shouldn't have picked to the power of 3. That's annoying. What else? I'm gonna make an executive. No, because some of you already did it. Okay, never mind. I was gonna say I'm just gonna change it to 2, but if you guys did the review before, that'd be rude. So let's just do it. I'm gonna rewrite all these as fractions because it'll be easier to deal with. That's gonna be, what's that? That's 7 over, no, not 7. That's 3 plus 4, 7 over 4. So it's 7. Okay. Over here, that's 13 over 4. Over here, that's going to be 19 over 4. And over here, that's going to be 25 over 4. Okay. So now I need to figure out all the values of f for all of these inputs. Let's start with M1. So it's 1 plus, oh God, 7 over 4 to the power of 3 plus 1. Well, we know the bottom will be 64. And then the top, 7 to the power of 3. Will be 343, and plus 1 will be 3 plus 64. Will be 1 over 407 over 64, which is just 64 over 407. F of M2 is 1 over 13 over 4 to the power of 3 plus 1. 13 to the power of 3. That's crazy. Is 2197 over 64. Wait, let me just double check that. 64 is okay, cool. Plus 1, which is, can be written as 2221 over 64. 64 over 2261. Yeah, I made a mistake by doing that one, but whatever. Definitely not doing that for the test. I mean, I already spoiled it. You're gonna get one of these questions on the test, but I'm definitely gonna make sure it's not something where it's this criminal to plug in. 1 over 19 over 4 to the power of 3 plus 1. Mm, 19 to the power of 3. That's going to be 6859 over 64 plus 1. So it's going to be 1 over 6923 over 64. 64 over 6923. And then the last one, M4. 1 over 25 over 4 to the power of 3 plus 1. 1 over, what's 25 to the power of 3? 15,625 plus 1, which I'm just going to skip to the final part, 64 over 15,689. Step 5, I'll do here. Step 5 is to add them all up and then multiply by 1/2. For this, I not 1/2, to multiply by the change. Before it was 1/2. I'm definitely just gonna cheese this. There's no way. Okay. If they all have a common factor of 64, so I'll take advantage of that. 1 over 407 plus 1 over 2261 plus 1 over 6923 plus 1 over 15689. And then all of this is multiplied by 1.5. And then, hold on. I accidentally, give me a second. I need to retype it again because I accidentally used the wrong calculator. Let's see. Okay, one more time. 1.5 times 64. So I'm factoring out the 64 of 1 over 407 plus 1 over 2261 plus 1 over 6923 plus 1 over 15,689. Wow. It says that it says that the fraction approximation is not possible because I'm using the Desmo Scientific Calculator. But either way, you should have gotten the answer of 0.298 rounded. Okay. All right. Let's use the trapezoidal rule next. So that one just says to find all of your f of x's. So let's start with f of x0. So 1 over 1 to the power of 3 plus 1, that's just 1 over 2. F of x, here, number 3 for this one. 1 is just 1 over 3 over 2 to the power of 3 plus 1. Let me double check that. 5, excuse me, 5. So that's going to be 1 over 125 over 4 plus 1. Now it gets simplified to 4 over 129. f of x2, 1 over 4 to the power of 3 plus 1. That's just going to be 1 over 65. F of x3 is no, not 19, excuse me, is 11 over 2 to the power of 3 plus 1. I don't even, what's 11 to the power of 3? So it is 1, 3, 3, 1 over, I did 4, it's 8, silly, 8, 8. 2 to the power of 3 is 8. Plus 1, in that case, I also added that incorrectly. That's going to be 8 plus that is 33. And 8 plus this is 8 over 1339. That's the x over 4. 1 over 7 to the power of 3 plus 1. 7 to the power of 3 is 3, 4, 3. It's just 1 over 3, 4, 4. Okay. All right. Now for step 4, I don't know this. These are too many varying bottoms, so I think I will just type it all in one go and just present the answer like this. So, excuse me. So you first type in. Yeah, I'm gonna do that live though. You first type in the rate of change. No, 0.5 times the rate of change, which is 1.5. And times the sum of all these, where the first and last terms are untouched, but everything in the middle is multiplied by 2. So that's 16 over 133 plus 2 over 65 plus 16 over 1339 and plus 1 over 344. Okay. So it's not wrong, but it is very different to what our original prompt was. I think here, let me just double check. 5. Here, let's see if I can do this. 1 over parentheses to power of 3 plus 1 of 5 over 2. Okay. Of 11. 11 over 2. Yeah, so those are right. Okay. Just double checking, you never know. So the answer is 0.499 if we're into 3 decimal places. Then for the last one, Simpsons. For 3, I'm copying these results. And then for 4, I'm just going to plug it in. We have 1 over 3 times the rate of change, which is 1.5, times the first guy, untouched, and then the second guy times 4. So 4, and I'll just do the fraction. 8133 plus 2 times this middle guy. 1 over 65. Wait. I don't want it to accidentally read as a mixed fraction, so I'll just multiply. I'll write the multiplication. Mm, 8 1339, and then plus the last one I touched 1/344. And this guy, the answer is 0.399. So all varying, but kind of in the same range, but not as like picture perfect as we'd like. Okay. All right. That was a lot, but we need to move on. Okay. So we have 4 more problems left. Let's do these 4 problems. Okay. So they all have an infinity trick behind them. Let's go ahead and go. I want to do, let's see, I have just a little orange left in this pen. Let's see if I can use it all up right now. Okay. Um, let's see. So the limit as t goes towards infinity of 0 to t of x e to negative x dx. For this one, this is an integration by parts. And then you also have to keep an account of, well, first we need to check if this exists everywhere throughout this bound. It definitely does, so we don't have to worry about anything like that. But let's go ahead and do, I'm going to do the integral on the side, actually. I do want to use a different color to denote I'm doing the integral on the side. The integral of x e to negative x dx. Which I think, do we redo? We did it here, so I'm going to go ahead and just abuse that. It's equal to negative x e to negative x minus e to negative x. And I have a feeling I might have to use that factoring, so I'm going to do a negative e to negative x times x plus 1. Okay. Then from here, I'm going to go ahead and use that. So limit as t goes to infinity of negative e to negative x plus 1 as we go from t to 0. Okay. For right here, I can already tell that this expression is going to go towards infinity, but this expression is going to go towards 0. So this whole thing will go towards 0. And then the limit does indeed. Oh, wait, I'm skipping a little bit of this. Yes, I definitely am. So I need to plug in the t's before I actually do that limit. Negative e, negative t of t plus 1 minus, which should be in positive, e to the 0, 0 plus 1. All this goes out to just be a 1, because that's 1 times 1. And this, as the limit applies, will become 0 plus 1, which is just 1. Just to double check my work, I'm gonna go ahead and graph it just real quick. Oh wait, well you're not really graphing. Let me graph this part, make sure that is going towards 0. Just in case I happen to be wrong. Which at the end of the day, I'm human. Plot twist, I know. Yeah, it's definitely 0. Okay. Beans. And this does converge. Oh wait, I did these. I don't know why I'm pretending like I haven't done these before. Let me check my formula just in case. Alright, we are goaded. Okay, next one, does this limit converge? It doesn't, it's not discontinuous anywhere between 0 and infinity. I mean, 1 and infinity, the bottom's at 0, so this can just be evaluated plainly. This though, right, forgot. Yeah, I was gonna say I did this too, so I'm just gonna go ahead and copy and paste that. First, let me rewrite it just a little bit. T1 ln of x over x squared dx is equal to the limit as t goes towards infinity of negative ln of x over x, and then minus 1 over x for t and then for 1. Okay, well, let's go ahead and plug everything in. We have the limit as t goes towards infinity of negative ln of t over t minus 1 over t, and then plus ln of 1 over 1 plus 1 over 1. I'm gonna go piece by piece. This, actually, I have a technical benefit. I'm gonna cheese it just a little bit. I'm gonna go ahead and combine these since they are combinable. And I'm gonna combine them to get negative ln, or not limit as t goes towards infinity of ln of t plus 1 over t. And then this is just, that's going to be a 0 and that's going to be a 1. And then from here, I think it's appropriate to just do L'Hopital. That's what I did, but I'm just re-looking at this just in case. No, just do L'Hopital. So, because this technically goes, as t goes towards infinity, this goes towards infinity. As t goes towards infinity, this goes towards infinity. So you do L'Hopital, this hospital. Can you have 1 over t over 1? And we know that that will go towards 0. So you have negative 0 plus 0 plus 1. So the whole answer is 1, and this does converge. Okay. Excuse me. Okay. Right. Let's move on to this one. And I think, where is it? I think that one I didn't do. Which ones were the ones I didn't do? Okay. I think it's just these two that I did. Okay, for sure. Sorry, it's been a bit. Okay. All right. So we can go ahead and perform this. I'm gonna perform the integral first on the side, just so that way I don't have to worry about it. We definitely need to use substitution trick. U is negative 3x. Du then is negative 3 dx. Negative 1 over 3 du is equal to dx. So the whole thing should be negative 1 over 3 integral e to the u du. And then it's negative 1 over 3 eu plus c, and then we replace it with the u. So e to the power of negative 3x plus c. Okay. All right. What am I missing? Nothing. Okay, so now let's go ahead and plug this in. This is definitely just continuous everywhere, so we don't have to worry about any tricks like that. So we're doing this of t0 e to negative 3x dx. Using this, we're going to go ahead and plug that in to be the limit as t goes to infinity of, I'll let the negative 1 over 3 escape, e to the negative 3x for t and 0. Okay, sorry, I was just looking at my solutions. We have negative 1 over 3, and then in parentheses we can write, or wait, I keep forgetting limits, excuse me. I'm in such a hurry, my bad. T minus e to the 0. This limit will just be going towards 0, and this one will be 1. So you have negative 1 over 3 of 0 minus 1, which is just 1 over 3. And this does converge. Okay. All right, last one. The bottom doesn't exist past the negatives. Oh, actually, well, it'd also be an issue if it was 1, but it's 2, so it doesn't matter. Okay. So let's go ahead and do this one. So this one is definitely going to be a u substitution because we see that ln's derivative 1 over x is present. So if I do 1 over x, 1 over ln of x squared dx, I'm just going to separate so it's more visible. And I do u to be ln of x and du to be 1 over x dx. Then this is just 1 over u squared du, which is just negative 1 over u plus c. And then we're replacing u to be ln of x plus c. Okay. Then we can go over here, the last one. From 2 to t, as t goes towards infinity, of 1 over x times the ln of x squared dx, which is just for the limit as t goes towards infinity of negative 1 over ln of x for t and 2. For this, I'll take out the negative and I'll evaluate 1 over ln of t minus 1 over ln of 2. The limit here, this bottom will go towards infinity, and that will cancel this guy out to where it's just going to be a 0. And then the limit of a constant is just the constant, so you have negative 0 minus 1 over ln of 2, which you can just simplify the answer to 1 over ln of 2. And that's where it converges, and that's the answer of our integral. Done. Whew, I am winded. So that was a long review, but I'm hoping that we got some good practice in. Maybe there's some points I clarified or some strategies you saw. Let me know if you guys have any questions about it, and I will see you all on Monday. Best of luck. I hope you kill it. And then also, hopefully, on Thursday, I'll have some grades posted, or day 4, whatever. I'll have grades posted for the test 1. All right, wish you best. Bye bye.